For as long as we have had stories, we have had a special place in them for our next-door neighbor in the cosmos. We have called it by the names of our gods of war, a testament to its deep and fiery red color. We have seen it as a source of mystery, of alien invaders, and of great and epic adventures. It is the Red Planet, is Mars. And in our modern age, this ancient and mythological world has transformed into something new. It has become a destination. It is the great and perhaps the necessary next step in the long and patient story of human migration. We are a species of explorers, of pioneers, of settlers. And Mars is our new and our greatest and our most challenging new world. The dream of living on Mars is no longer just a fantasy. It is a real and a tangible and a scientific and an engineering goal that our species is actively working towards. But the Mars of our science fiction stories is often a place of grand and of heroic adventure. The Mars of reality is a quieter, a colder, and a far more challenging place. The story of living on Mars is not a story of great battles and of epic conquests. It is a story of quiet and of patient and of meticulous survival. It is a story of science, of engineering, and of profound and of psychological and of human resilience. It is a story of what it would truly and actually be like to call this strange and this beautiful and this deeply hostile world our home. This journey tonight is a calm and a detailed and an honest exploration of that future. We will travel together in our quiet vessel of the mind to our potential new home, and we will explore, one gentle step at a time, the profound challenges and the even more profound beauty of what it would truly mean to live on the planet Mars. Before we embark on this long and quiet and 7-month-long voyage to our potential future home, I would love to know from which part of our own blue and white and life-giving planet you are joining us tonight. Please write your city or your country in the comments below. It is a beautiful way to feel our shared terrestrial connection as we prepare in our minds to take the great leap outwards. And if you enjoy these calm and these deep and these educational explorations of our future in the cosmos, please consider subscribing to the channel. Your support is the quiet energy that allows us to continue these journeys together, always calmly, always at the pace of the universe. The story of our future on Mars is a long and a complex one, a story with many different and beautiful chapters, and on our journey tonight, we will explore them all. Our journey will begin, as it must, with the voyage itself, the long and the perilous and the 7-month-long transit through the cold and the dark and the unforgiving vacuum of interplanetary space. From there, we will arrive at our destination, and we will explore the strange and the beautiful and the deeply alien environment of the Red Planet. We will stand in our minds under its thin and its pinkish and its carbon dioxide sky. We will witness its faint and its small and its distant sun, and its beautiful and its famous blue sunsets, and we will shiver in its profound and its life-threatening cold. Then we will turn our attention to the great and the quiet and the brilliant science of survival. We will explore the ingenious technologies that will be needed to build our first home, our first habitat on this new world. We will learn how the first Martians will breathe, how they will find and recycle every precious drop of water, and how they will learn to grow food in the sterile and the toxic soil of an alien desert. And finally, we will explore the most profound questions of all. We will explore the quiet and the deep and the human challenges of living on Mars. And we will look to the far, far future, and we will explore the greatest and the most audacious of all our dreams, the multi-millennial and the beautiful, and the almost impossible dream of one day terraforming Mars, of giving our neighbor world a blue sky and a flowing river and a living ocean of its own. And so, let us now take a quiet and a deep breath, and let us together step aboard our imaginary starship and begin the long and the silent and the beautiful journey to our future home. The journey to our future home on Mars begins not with a single great leap, but with a long and a patient and a quiet voyage across an immense and an unforgiving ocean. The distance between our world and the red planet is not a constant. It is a shifting and a dancing and a dynamic gap, as both planets follow their own steady and graceful orbits around the Sun. But even at its very closest, the distance is still a colossal 34 million miles, or 55 million kilometers, and the journey, following the most fuel-efficient and the most logical path, is a long one. It is a voyage that will last for some 7 to 8 months, a period of time longer than many classic ocean crossings, and comparable to the longest legs undertaken by the first terrestrial explorers. The first generation of Martians will not be sprinters. They will be long-distance voyagers, and their ship will be their entire world for more than half a year. The path they will follow is a beautiful and a graceful one. A spacecraft does not travel to Mars in a straight line, as one might first imagine. To do so would require an almost unimaginable amount of fuel. Instead, the journey is a long and a quiet coast, a beautiful, arcing trajectory that is dictated by the immense and the ever-present gravity of the Sun. After its powerful launch from the surface of the Earth, the spacecraft will fire its engines for one brief and crucial burn. This is the trans-Martian injection. This single push of the engines is just enough to place the spacecraft on a new and a larger and an elliptical orbit around the Sun, an orbit that is so perfectly and so precisely calculated that its farthest point, its aphelion, will exactly intersect with the orbit of Mars, just at the precise moment that Mars itself is arriving at that same point in space. It is an act of almost unimaginable celestial navigation. And for the 7 months that follow that one single burn, the ship's engines will be silent. The crew will be in a state of a continuous and a beautiful and a silent freefall. Their tiny metal home a new and a temporary and an artificial planet, coasting on its long and patient journey, guided only by the gentle and the invisible and the perfect hand of gravity. But this long and silent voyage is a perilous one, for the great and the dark ocean of interplanetary space is not a benign or a gentle place. It is an environment that is profoundly and deeply hostile to human life. And the first and the most insidious of all the dangers is an invisible one: radiation. Here on Earth, we are protected by a beautiful and a complex 2-layered shield. We are protected by our planet's strong magnetic field, which deflects the most energetic particles from the Sun and the galaxy. And we are further protected by our thick and our life-giving atmosphere. In the deep space between the planets, an astronaut has neither of these things. They are completely and utterly exposed. They are subject to a constant and a deeply penetrating rain of 2 kinds of radiation: the occasional and the violent and the unpredictable burst of a solar flare from our own Sun, and the even more dangerous and the constant and the high-energy shower of galactic cosmic rays, the atomic nuclei that have been accelerated to near the speed of light by distant and by long-dead supernova explosions. The spacecraft itself must be a kind of radiation shelter, its walls perhaps lined with water, or with special, hydrogen-rich plastics, to absorb as much of this energy as possible. The second great challenge is the journey's effect on the human body itself. For 7 long months, the crew will be in a state of continuous zero gravity. The human body is a machine that has been perfectly and beautifully designed by billions of years of evolution to work within the constant and the gentle and the familiar pull of Earth's gravity. And when that pull is removed, the body begins to change in profound and in damaging ways. With no need to fight against gravity, the muscles of the body begin to waste away, a process known as atrophy. And the bones, with no weight to support, begin to shed their own density, a condition that is very similar to osteoporosis. To fight this, the first Martian explorers will need to spend several grueling hours every single day strapped to complex exercise machines just to convince their own bodies that they are still needed. And the final and perhaps the most profound of all the challenges is the psychological one. To be one of the first human beings to travel to Mars would be a great and a historic honor. But it would also be a journey of an almost unimaginable isolation. For the first few days of the voyage, the Earth would hang in the window of the spacecraft as a beautiful and a familiar and a shrinking blue and white marble. But soon, it would diminish to become just the brightest and the bluest star in the sky. And for the vast majority of the 7-month-long journey, the view from the window would be almost completely and totally unchanging. A view of the brilliant and the unfiltered and the unblinking sun on one side of the ship, and a view of a perfect and a silent and a star-dusted and an eternal blackness on the other. The crew would be living in a tiny and a fragile and a metal can, a single living island in an ocean of a profound and an almost absolute emptiness, hundreds of millions of miles away from every other human being that has ever existed. After a long and a quiet and a 7-month-long journey across the dark and empty ocean of interplanetary space, our travelers have finally reached their destination. The small and the reddish and the star-like point of light that has been their goal for so long has now grown in the forward viewport to become a great and a ruddy and a beautiful and a silent globe. They have arrived at the planet Mars. The long and the patient and the coasting part of their voyage is now over, and the final and the most brief and the most intense and by far the most dangerous part of their journey is about to begin. To live on Mars, one must first arrive there. And the process of arriving, of slowing down from a speed of thousands of miles per hour to a gentle and a perfect touchdown on the surface, is one of the most difficult and the most unforgiving challenges in all of human engineering. The first great act of this final ballet is the orbital insertion. The spacecraft is arriving at Mars at a colossal speed, and to enter into a stable orbit, it must perform a single, a perfect, and a precisely timed retropropulsive burn of its main engine. It is a moment of the highest possible stakes. If the engine burns for too short a time, the spacecraft will not lose enough velocity, and it will fly right past the planet, its trajectory carrying it out into the deep and the unrecoverable darkness of the outer solar system. If the engine burns for too long, it will slow down too much and will begin an uncontrolled and a fatal descent into the atmosphere. The maneuver must be perfect. And so, with a quiet and a computer-guided precision, the engine fires, a brief and a brilliant star in the darkness, slowing the great ship down until it is finally and beautifully captured by the gentle and the patient gravity of the red planet. The crew is now in a safe and a stable orbit, a new and a temporary and a human-made moon of Mars. But the true and the final challenge still lies ahead. The journey from a stable orbit down to the surface is a process that NASA engineers have famously and rightly called the 7 minutes of terror. And the most terrifying part of these 7 minutes is the silence at the time of arrival. A one-way communication delay between Mars and the Earth can be as long as 22 minutes, about 44 minutes round trip. This means that the entire, complex, and incredibly dangerous sequence of entry, of descent, and of landing must be completely and totally automated. The crew and the great and the hopeful and the listening world back on Earth are now just passengers. Mission Control is now just an audience, waiting for a signal that will tell them of a success or a failure that has already happened millions of miles away, many minutes in the past. The great and the final plunge begins. The landing vehicle separates from the main orbiting spacecraft, and it fires its thrusters one last time to begin its descent. It hits the outermost and the most tenuous layers of the Martian atmosphere at a speed of more than 12,000 miles per hour. For the next few minutes, the vehicle is a meteor, a man-made shooting star, its great heat shield glowing a brilliant and a beautiful, and a fiery orange as the friction from the thin carbon dioxide air slows it down with an incredible and a violent force. When the vehicle has slowed to a speed of roughly 400 meters per second, about Mach 1 in the Martian atmosphere, the next great and dramatic and beautiful event occurs. A massive and a specially designed supersonic parachute is deployed from its back shell. It unfurls in a fraction of a second, a great and a beautiful and a fragile-looking mushroom in the thin pink sky, and it snaps taut with an almost unimaginable force, slowing the vehicle's descent even further. But the atmosphere of Mars is less than 1% as dense as the Earth's, and so a parachute alone is not enough to bring a heavy, human-rated lander to a gentle stop. And so, in the final moments of the descent, the last and the most complex part of the ballet begins. The heat shield is jettisoned, and a set of powerful, downward-facing retro-rockets, the final braking system, ignites. In the final few hundred feet, propulsive descent and aerial hoist system, drawing on concepts proven with robotic missions but scaled for crude payloads, will take over, lowering the precious cargo, the habitat and the crew on strong and steady tethers. And then, after a 7-month-long journey and 7 long minutes of a perfectly choreographed automated terror, a quiet and a gentle and a beautiful and a final touchdown. The engines fall silent, the dust begins to settle, and for the first time in the 4.5 billion-year history of this ancient and this silent world, a human crew is safely on its surface. Their long journey is over. But their new life on this strange and this beautiful and this deeply alien world has only just, in this one quiet and historic moment, truly begun. The great and perilous journey is over. The 7 minutes of a perfectly choreographed automated terror have come to a quiet and a successful end. The landing engines have fallen silent. The fine red dust that was kicked up by their final, powerful blast begins to settle in the thin, alien air, and inside the small and the safe and the quiet habitat, the first human crew on Mars takes a collective and a historic and a deeply held breath. They have arrived. They are the first representatives of our species to set foot on another world. And now, for the very first time, a human eye is about to look out of a window and to gaze upon the strange and the beautiful and the completely alien landscape of our new home. The view is one of a profound and a majestic and a silent desolation. Before them stretches a vast and a rolling and an empty plain of reddish-orange sand and rock, a great and a rusty and a global desert that has been untouched and unchanged for billions of years. The horizon is sharp and it is clear, and it is closer than a familiar terrestrial horizon, a subtle and a gentle reminder that this is a smaller and a more intimate world than the one they have left behind. And above this silent and this ancient and this ruddy landscape is the first and the most striking of all the great Martian wonders. The sky. The sky of Mars is not blue. It is a thin and a gentle and a beautiful and a dusty butterscotch or a pale salmon pink. This strange and beautiful color is a direct consequence of the planet's thin atmosphere and its fine red dust. On Earth, our thick and our dense and our nitrogen-rich atmosphere is very good at scattering the short blue wavelengths of light from our sun, a process that paints our daytime sky in its familiar and its beautiful and its vibrant blue. But the atmosphere of Mars is less than 1% as dense as our own, and it is filled with tiny and with microscopic and with rust-colored particles of iron oxide dust, which are permanently suspended in the thin air. And these tiny red dust particles are very good at scattering the longer red wavelengths of light, giving the entire sky this soft and this eerie and this beautifully alien pinkish glow. The quality of the light is different too, because Mars is, on average, 1.5 times farther from the Sun than the Earth is. The Sun itself appears smaller in the Martian sky, only about 2/3 the size that we are used to, and the sunlight that falls upon the landscape is a thinner and a colder and a less energetic light. The brightness of a clear Martian noon is not the bright and the harsh and the direct glare of a summer's day on Earth. It is a more gentle and a more diffuse and a more melancholic light, similar perhaps to the light of a bright and a slightly overcast afternoon here on our home world. And as the long and the slow and the quiet Martian day draws to a close, this strange and beautiful sky performs its most famous and its most paradoxical and its most breathtaking trick. The sunset on a pink planet is a brilliant and a vivid and a startling blue. As the small white disk of the sun sinks towards the horizon, its light must now travel through a much longer and a much thicker path of the thin and the dusty atmosphere. And as it does so, the same fine red dust particles that scatter the red light across the sky during the day now act to scatter the red light away from our direct line of sight. This allows the shorter and the more direct and the blue wavelengths of light to penetrate through, creating a spectacular and a deeply moving and an almost perfectly blue-colored glow in the sky immediately surrounding the setting sun. And then the night arrives, and the Martian night sky is another world of strange and of beautiful wonders. It is a sky with not one, but 2 moons. But they are not like our own, great and majestic and silver moon. They are 2 tiny and misshapen and captured asteroids named Phobos and Deimos. The inner moon, Phobos, is so close to the planet that it orbits Mars faster than Mars itself rotates. This creates a strange and a beautiful spectacle. It would rise in the west, and it would race across the sky, a fast-moving and a potato-shaped and a silent object to set in the east only a few hours later. The outer moon, Deimos, is much smaller and much farther away, and it would appear as little more than a very bright and a very slow-moving star, and neither of these tiny moons is large enough to cast any significant moonlight upon the landscape. The Martian nights are profoundly and beautifully and almost absolutely dark, a perfect and a pure and an unfiltered canvas for the brilliant and the undimmed and the silent light of the distant stars. The first look out upon the Martian landscape is a moment of profound and of beautiful and of alien wonder. We have now in our journey stood under its strange and its pinkish and its butterscotch sky. We have witnessed the spectacle of its small and its distant and its white sun sinking below the horizon, painting the sky around the setting sun in a beautiful and an impossible shade of blue. And we have seen its 2 small and captured moons, Phobos and Deimos, as they race across the brilliant and stardusted and the deeply dark night, faintly accompanied by 2 tiny moons. This new and beautiful sky is a spectacle that would inspire a new generation of artists and of poets. But this visual beauty, as profound as it is, hides a much deeper and a much more dangerous and a much more hostile truth. To survive on Mars, one must do more than just look at its sky. One must understand its air. And the thin and the cold and the unbreathable atmosphere of the red planet is the first and the greatest and the most immediate of all the challenges that the first Martian colonists must overcome. Let us first consider its composition. The air that we are breathing right now, the beautiful and the life-giving air of our own home world, is a rich and a complex and a nourishing mixture. It is roughly 78% nitrogen, a gentle and an inert buffer gas. It is 21% oxygen, the essential and the precious and the energetic fuel for our own and all of animal life. And it contains a host of other important trace gases. The atmosphere of Mars, by contrast, is a profoundly and a deeply alien one. It is composed of more than 95% carbon dioxide. This is a gas that is, for us, a waste product, a gas that we exhale with every breath, and a gas that is toxic to us in any high concentration. The remaining small fraction of the Martian air is a mix of nitrogen and of argon, with only the most fleeting and the most insignificant and the most utterly unbreathable trace of free oxygen. Less than 0.2%. The first and the most simple and the most absolute rule of living on Mars is a simple one. One cannot breathe the air. But the unbreathable nature of the air is not even its most immediate danger. The second, and the even more profound challenge, is its almost complete lack of pressure. The Martian atmosphere is incredibly and almost unimaginably thin. The average atmospheric pressure at the surface of Mars is less than 1% of the air pressure that we feel here on Earth at sea level. To stand on the surface of Mars is the pressure equivalent of being at an altitude of more than 100,000 feet, or 30 kilometers, in the Earth's own atmosphere. This is 3 times higher than the cruising altitude of a commercial jetliner. It is a near vacuum. And this incredibly low pressure has a strange and a violent and a deeply counterintuitive effect on the human body. It is a phenomenon known as the Armstrong limit. At this extremely low pressure, the boiling point of water, which is 100 degrees Celsius here on Earth, drops all the way down to the normal and the healthy and the 37 degrees Celsius temperature of the human body. This means that an unprotected human stepping out onto the surface of Mars would experience a horrific and an almost instantaneous death. The liquid saliva on their tongue, the gentle, wet tears in their eyes, and most catastrophically, the thin and the delicate and the wet lining of their own lungs would all begin to spontaneously and to violently boil. And even beyond these two fatal challenges, this thin and this beautiful and this pinkish atmosphere offers almost no protection from the harshness of space itself. Here on Earth, our thick and our dense atmosphere is a powerful and a beautiful shield. It absorbs the most dangerous and the most high energy and the most damaging of the sun's ultraviolet radiation, and it acts as a great and a protective and a beautiful blanket against the constant and the invisible rain of high-energy galactic cosmic rays. The thin atmosphere of Mars provides almost none of this protection. The surface of the planet is constantly being bathed in a high and a dangerous dose of both solar and cosmic radiation, a dose that would be a significant and a long-term health risk for any human colonists. And finally, this thin air offers almost no protection from impacts. Our own thick atmosphere is a beautiful and a powerful shield against all but the largest of incoming meteoroids, burning them up as beautiful and as fleeting and as harmless shooting stars. The thin atmosphere of Mars is not dense enough to do this. The Martian surface is constantly being bombarded by a rain of micrometeorites and is at a much, much higher risk of a significant and a dangerous impact from a larger object. The beautiful and the pink and the alien sky of Mars, then, is a profound and a beautiful paradox. It is a vision of a quiet and a gentle and an almost serene beauty. But it is a beauty that hides a deep and a profound and an utterly lethal hostility. The thin and the beautiful and the profoundly hostile air of Mars has now revealed its secrets to us. We have, in our quiet journey, come to understand that the Martian sky is a beautiful veil that hides a deep and an almost absolute lethality. Its unbreathable composition, its near vacuum pressure, and its almost complete lack of a protective shield make it an environment where an unprotected human life could not survive for more than a few brief and terrible moments. The first and the most fundamental rule of living on Mars is that one must live inside, forever separated from the alien air by the safe and the life-giving and the artificial bubble of a habitat. But the atmosphere of Mars has another, and an equally profound and an equally challenging story to tell. It is the story of the planet's climate, a climate of the most profound and the most violent of all possible extremes. Let us begin with the temperature. The thin and the 95% carbon dioxide atmosphere of Mars is incredibly and profoundly inefficient at trapping and at distributing the heat from the sun. Here on Earth, our thick and our nitrogen-rich atmosphere acts as a great and a beautiful and a global blanket, holding on to the warmth of the day and keeping our nights relatively mild. The thin air of Mars has no such ability, and the result is a world of the most breathtaking and the most challenging temperature swings imaginable. Let us imagine for a moment that we are standing on the equator of Mars, at the height of a beautiful and a calm summer's day. The small and the white and the distant sun is high in the thin and the pinkish sky. At this moment, the ground beneath our feet could reach a comfortable and a deceptively pleasant 20 degrees Celsius, or about 70 degrees Fahrenheit. It is a beautiful and a temperate and a gentle warmth. But this warmth is a fleeting and a shallow illusion. For the moment that the sun dips below the horizon, the temperature begins to plummet with a catastrophic and an almost unbelievable speed. With no atmospheric blanket to hold on to the day's heat, all of that energy radiates away, almost instantly, into the blackness of space. And by the deep and the dark of the pre-dawn morning, the temperature on that same equatorial spot can have dropped to as low as minus 73 degrees Celsius, or minus 100 degrees Fahrenheit. A daily temperature swing of nearly 100 degrees Celsius, a violent oscillation between a pleasant summer's afternoon and the deepest and the most profound of all Arctic winters every single day. And this is at the warmest part of the planet. As one travels towards the Martian poles, the cold becomes even more absolute. During the long and the dark and the polar winters, the temperatures can drop to below minus 125 degrees Celsius. It is a cold so profound, so absolute, that the very air itself begins to freeze. The carbon dioxide of the atmosphere will condense directly onto the surface, burying the great polar water ice caps under a new and a seasonal and a brilliant white layer of dry ice. And Mars, just like the Earth, has seasons. Its axis is tilted by about 25 degrees, a tilt that is remarkably similar to our own. But the orbit of Mars is much more stretched out, much more elliptical than the Earth's nearly circular path. And this means that the seasons on Mars are not of an equal length, and their severity is dramatically affected by the planet's distance from the sun. The southern hemisphere, for example, experiences a winter that is both much longer and much, much colder than the winter in the north. This great imbalance in the seasons drives a vast and a beautiful and a planetary scale annual cycle, A significant fraction of the entire planet's atmosphere will freeze out onto one of the polar caps during its winter, only to sublimate back into the air during its summer. The entire planet, in a very real sense, is breathing, its atmosphere growing and shrinking with the slow and the patient and the beautiful rhythm of its long and its unequal seasons. And all of this, the great temperature swings and the seasonal breathing, gives rise to the most famous and the most dramatic and the most dangerous of all the Martian weather phenomena, the great dust storms. These storms can begin as small and as local and as relatively harmless dust devils, small whirlwinds of air that are common on the Martian plains. But under the right conditions, these small storms can grow and can merge and can feed off the sun's energy, and in a matter of weeks, they can blossom into a single, colossal, and planet-encircling storm, a great and a global and a dusty tempest that can shroud the entire planet in a thick and a dark and a reddish haze for months at a time. The winds in these storms, because the air is so thin, would not have the destructive physical force of a hurricane here on Earth. But the dust they carry, a fine and a gritty and an abrasive and an almost inescapable powder, would be the true danger. It would cover the vital and the life-giving and the precious solar panels of any human settlement, cutting off its primary source of power and plunging the first Martians into a long and a dark and a potentially very dangerous and a very cold and a very quiet and a very patient wait for the sun to return. The first human explorers have now arrived on Mars. They have endured the long and the silent and the perilous 7-month-long voyage across the interplanetary void. And they have survived the brief and the violent and the perfectly choreographed terror of their automated landing. Their small and their fragile and their precious lander now rests in a profound and a historic silence on the vast and the cold and the rusty and the ancient desert plains of the Red Planet. They have looked out upon the alien sky and have taken in the majestic and the desolate beauty of their new home. But the true and the great and the patient work of survival has only just begun. For to live on Mars is to live in a state of a constant and a vigilant and a technological siege. And the first and the most fundamental of all the requirements for survival is the need for a shelter, a home, a tiny and a precious and a carefully constructed bubble of Earth, a sanctuary against the profound and the almost absolute hostility of the Martian environment. The choice of where to build this first great off-world home is a critical one. The first Martian base will almost certainly be located in the planet's relatively flat and equatorial mid-latitudes. This is a region that receives the most reliable sunlight throughout the long Martian year, a crucial factor for a settlement that will rely primarily on solar power, complemented by modular fission reactors for resilience during dust storms. And even more importantly, the first habitat must be built in a location that is in close proximity to a large and inaccessible reservoir of a single and a most precious resource, water ice. Recent orbital surveys have revealed that there are vast and ancient and almost perfectly pure glaciers of water ice, buried just a few feet beneath a protective layer of red dust, in regions like Arcadia Planitia. And it is here, above one of these great and hidden and life-giving rivers of ice, that humanity will likely build its first true Martian town. The architecture of this first home will be a story of a beautiful and a necessary and an ingenious compromise between what is brought from Earth and what can be found on Mars itself. The very first habitats will likely be prefabricated, inflatable structures carried from Earth and then expanded on the Martian surface. But a simple, thin-walled dome is not enough. The surface of Mars, as we have learned, is constantly being bathed in a dangerous and a deeply penetrating dose of solar and of cosmic radiation. And so, The first great task of the new colonists will be to bury their home. Using autonomous robotic bulldozers and excavators, they will pile a thick and a heavy and a protective blanket of the Martian soil itself, the regolith, over their inflatable habitat, creating a great and a gentle and a life-saving mound. The first Martians will, in a very real sense, be living in a kind of sophisticated and a high-tech and a beautiful and a necessary underground bunker. But a more elegant and a much more permanent solution likely lies in the great and the natural and the ancient caves that are hidden just beneath the Martian surface. In its distant and its fiery and its volcanic past, Mars was a world of great and of flowing and of molten rivers of lava. And as these rivers cooled, they often formed vast and hollow and underground tunnels, some of which are hundreds of meters wide and many miles long. These are the Martian lava tubes. And they are, in a very real sense, the perfect and the pre-made and the natural real estate for a future human civilization. A great and a stable and a natural cave, its ceiling dozens of meters thick with solid basaltic rock, provides an almost perfect and a completely free shield from the constant rain of radiation and of micrometeorites. And deep within these caves, the temperature is not subject to the wild and the 100-degree swings of the Martian surface. It is a constant and a stable and a relatively mild and a predictable temperature, day and night, all year round. And to build these great and these permanent and these future homes, the colonists will have to learn to live off the land. It is simply too expensive and too difficult to ship every single brick and every single building material from the Earth. And so, the great and the foundational technology of a future Martian settlement will be the science of in-situ resource utilization. The colonists will use great and robotic and solar-powered 3D printers, and for their ink, they will use the most abundant of all Martian resources, the red and the dusty and the iron-rich soil itself. By mixing this regolith with a small amount of a binding polymer brought from Earth, these great machines will be able to print, layer by patient layer, the landing pads, the roadways, the radiation shields, and even the great and the solid and the pressurized walls of the habitats themselves. And inside these habitats, whether they are buried under the red soil or nestled in the silent and the ancient and the deep protection of a great lava tube cave, the environment will be a small and a precious and a carefully managed and a beautiful bubble of earth. It will be a place of a warm and a breathable and a nitrogen and oxygen-rich air. It will be a place of a clean and a recycled and a life-giving water. And it will be a place of a bright and an artificial and an earth-like light, a light that is tuned to the familiar and the 24-hour and the circadian rhythm of a world that is now hundreds of millions of miles away. The first human home on Mars has now been established. Whether it is a sturdy, inflatable habitat buried for protection under a thick and a dusty blanket of the red Martian soil, or whether it is a great and a beautiful and a permanent settlement built within the silent and the ancient and the deep protection of a colossal underground lava tube, the first Martians now have a sanctuary. They have a small and a precious and a carefully constructed bubble, a tiny outpost of Earth that can shield them from the profound and the almost absolute hostility of the Martian environment. But a strong and a sturdy wall is only the very first requirement for survival. The true and the constant and the most life-critical of all the challenges of living on Mars is the patient and the unending and the technological task of creating and of maintaining a perfectly breathable and a perfectly hydrated and a perfectly Earth-like environment inside that bubble forever. Here on Earth, our planet performs this service for us for free. On Mars, It is a constant and an energy-intensive and a beautiful and an ingenious act of technological life support. Let us first consider the most immediate and the most necessary of all our needs, the very air we breathe. A human being can survive for weeks without food and for days without water, but can only survive for a few brief minutes without a steady and a reliable supply of oxygen. And to ship the colossal amount of compressed oxygen that would be needed for a long-term human settlement all the way from Earth is a logistical and a financial impossibility. The oxygen for our Martian home must, therefore, be created on Mars itself. And the beautiful and the paradoxical and the ingenious secret to this is that the raw material for our breathable air is the unbreathable Martian atmosphere itself. As we have learned, the thin and the cold and the toxic air of Mars is made of more than 95% carbon dioxide. The chemical formula for this gas, CO2, tells us everything we need to know. Each and every molecule of the Martian air contains one atom of carbon and two precious atoms of oxygen. The oxygen is there, in an almost infinite abundance. It is just locked up in the wrong chemical form. And so, the first great, life-giving machine of any Martian settlement will be a kind of mechanical and a robotic and an artificial tree. It will be a machine that can breathe in the thin and the carbon dioxide-rich air of Mars, and can, through a beautiful and an elegant process of chemistry, exhale pure and life-giving and breathable oxygen. This is not a science fiction fantasy. It is a technology already demonstrated on the surface of Mars. The Perseverance rover, exploring Jezero crater, carried a small, toaster-sized experimental device called MOXIE, which stands for the Mars Oxygen In-Situ Resource Utilization Experiment. The MOXIE instrument patiently and methodically pumps in the Martian atmosphere, and it then heats it to a very high temperature, about 800 degrees Celsius, and then, using a process called solid oxide electrolysis, it sends a powerful electrical current through this superheated gas. A current which literally cracks the carbon dioxide molecules apart, splitting them into pure breathable oxygen and carbon monoxide, which is then harmlessly vented back out into the Martian air. A future and a full-scale and a human settlement on Mars will have a much larger and a much more powerful and a permanent version of this beautiful and this life-giving and this almost magical machine, a great and a technological and a silent lung for our new human world. And the second great and equally important challenge is the challenge of water. Like oxygen, water is simply too heavy and too bulky to be transported from the Earth in the vast quantities that a permanent settlement would need. And so, the water for our Martian home must also be found and must be harvested on Mars itself. And we now know from the beautiful and the detailed maps that have been made by our orbital probes that Mars has colossal and almost unimaginable quantities of water, all of it frozen as solid and almost perfectly pure water ice. This ice is found in the great and the beautiful and the layered deposits of the polar ice caps, and, more accessibly, it is found as great and as thick and as ancient and as buried glaciers in the planet's mid-latitudes. And so, the second great and life-giving machine of our Martian settlement will be a great and an automated and a robotic water mining operation. These machines will patiently and methodically scrape away the top few feet of the dry and the dusty and the red Martian soil to expose the brilliant and the white and the ancient water ice that lies beneath. And then, by simply and gently heating this ice, they will cause it to sublimate into water vapor, which can then be collected and recondensed into pure and beautiful and life-giving liquid water. And once this water is brought inside the habitat, every single and precious and beautiful drop of it will be used and will be purified and will be recycled in a perfect and a beautiful and a closed-loop system, a miniature and a perfect and an artificial water cycle, the great and the technological and the life-giving and the beating heart of our first true and beautiful and permanent home on another world. The great and the quiet and the life-giving machines of our first Martian home are now at work. The silent and the robotic and the artificial trees are patiently cracking the thin and the toxic Martian air and are exhaling a steady and a precious stream of pure, breathable oxygen. And the great and the automated and the tireless mining robots are gently scraping away the red dust to harvest the ancient and the beautiful, and the pristine water ice that lies just beneath the surface. The two most fundamental and most life-critical of all our needs, the need to breathe and the need to drink, have now been met, not by a fragile and a finite supply that has been carried from Earth, but by the beautiful and the elegant and the sustainable process of living off the land. But a human life, a rich and a healthy and a meaningful life, requires more than just air and water. It requires nourishment. And so we now come to the third and the most complex, and in many ways the most beautiful of all the challenges of Martian survival. We must now, in our journey, learn how to build a garden on a world where nothing has ever grown before. The dream of a Martian farm is a beautiful one, a vision of green and of vibrant life, thriving under an alien sun. But the reality of this challenge is a profound and a difficult one. The soil of Mars, the fine and the red and the dusty regolith that covers the entire planet, is not like the rich and the dark and the fertile soil of our own home world. It is, in a very real sense, a dead soil. It is a sterile and a pulverized and an ancient rock dust, a material that is completely devoid of the complex and the organic and the microbial life that makes our own soil a living and a breathing entity. And to make matters worse, the Martian soil is also a toxic one. It is permeated with a class of reactive and of corrosive salts known as perchlorates, a substance that is deeply harmful to most forms of terrestrial life. The great task of any Martian farmer, then, is not to plant a seed. It is to heal the very ground itself. The process of creating the first small patch of living Martian soil will be a slow and a patient and a beautiful act of planetary alchemy. The raw and the toxic and the lifeless regolith will first be brought inside the habitat, and it will be gently and methodically washed with water, a process that will leach out and remove the harmful perchlorate salts. This cleaned and this now sterile and this mineral-rich dust will then become the base, the blank canvas, upon which our new and our alien and our beautiful garden will be built. To this clean sand, the Martian farmers will begin to add the precious and the carefully chosen ingredients of life. They will add the recycled and the composted and the organic waste from the habitat itself. And most importantly, they will introduce a carefully curated and a beautiful ecosystem of our own, terrestrial microbes, the tiny and the invisible and the hard-working bacteria and fungi that are the true and the silent and the patient architects of any healthy and of any living soil. For months, and perhaps for years, this first small batch of Martian soil will be tended and will be fed and will be cared for like a precious and a delicate sourdough starter, until it has been transformed from a dead and a red and a mineral dust into a rich and a dark and a living and a fertile and a beautiful and a precious and a priceless handful of earth. And it is only now, in this new and this living and this carefully created soil, that the first seed can finally be planted. The first Martian farms will not be great and open and sprawling fields. They will be contained and they will be controlled, and they will be beautiful, and they will be almost sacred spaces. They will be great and multi-layered and hydroponic and aeroponic vertical farms, all housed within the safe and the pressurized and the protected environment of the habitat. And the light that feeds these first green and beautiful Martian plants will not be the faint and the distant and the weak light of the Martian sun. It will be the bright and the intense and the perfectly tuned and the beautiful purple and red glow of a vast and an efficient array of LED lights. The first crops to be grown will be chosen for their resilience, for their efficiency, and for their nutritional value. Leafy greens like lettuce and spinach, hardy root vegetables like potatoes and sweet potatoes, and protein-rich legumes like soybeans and peas. The sight of the first green leaf unfurling in the purple light of a Martian greenhouse will be a moment of the most profound and the most beautiful and the most hopeful significance. It will be a quiet and a gentle and a beautiful and a final act of transformation. It will be the moment that our small and our fragile and our technological bubble on Mars ceases to be just a shelter and becomes, in a very real and a very true and a very beautiful sense, a self-sustaining and a living and a breathing home. The first human home on Mars is now a beautiful and a functioning and a self-sustaining and a living ecosystem. The great and the quiet machines are patiently breathing in the thin and the toxic Martian air and are exhaling a steady and a precious and a life-giving supply of oxygen. The automated water miners are harvesting the ancient and the pristine and the frozen water from the Martian soil. And the complex and the beautiful recycling systems are ensuring that not a single precious drop is ever wasted. And in the warm and the purple and the artificial light of the great subterranean greenhouses, the first and the most precious and the most hopeful of all Martian harvests are beginning to grow. The great and the immediate and the life or death challenges of survival have now been met. And so, the first colonists can at last begin to adapt to a new orbit. And a more subtle and a much more permanent and a much more profound feature of their new home. They can begin to adapt to a life in a lighter world. They must now learn to live with the gentle and the constant and the beautiful and the deeply transformative pull of Martian gravity. The force of gravity on the surface of Mars is only about 38% as strong as the gravity of the Earth. This is a simple number, but its consequences are immense, and they would be felt in every single moment of a colonist's life. A person who weighs 180 pounds on Earth would, on Mars, weigh only about 68 pounds. They would feel a profound and a beautiful and an almost dreamlike sense of lightness. The first steps taken on the Martian surface would be a revelation. Walking would become a new and a joyful experience, but gentle and a loping and a bouncy kind of stride. Running would feel almost like flying, and the simple act of jumping would be transformed into a beautiful and a slow motion and a graceful leap that could carry a person many feet into the air. Heavy equipment that would require a crane to lift on Earth could be moved and managed by a single person with an almost superhuman ease. This initial and this beautiful and this almost intoxicating sense of physical freedom and of newfound strength would be one of the great and the simple and the daily joys of living on a new world. But this gentle and this weaker and this forgiving gravity also hides a much deeper and a much more insidious and a much more long-term danger. For the human body is a magnificent and a beautiful and an incredibly efficient machine, and it has been perfectly and beautifully adapted over millions of years of evolution to the constant and the powerful and the unyielding stress of Earth's own strong gravity. And when that stress is removed, the body in its deep and its quiet and its unconscious wisdom begins to make a simple and a logical assumption. It assumes that its own strong and its heavy and its powerful terrestrial architecture is no longer needed, and it begins, slowly and silently, to deconstruct itself. This is the great and the quiet and the patient challenge of long-term life on Mars. The first and the most serious of these challenges is the effect on the human skeleton. Our bones are not static and unchanging structures. They are living tissues, constantly and patiently remodeling themselves in response to the loads they are under. And without the constant and the heavy and the familiar stress of Earth's gravity, the body will begin to shed its own unneeded bone mass at a rate of about 1 to 2% every single month. This is a silent and a profound and a dangerous condition, a kind of accelerated osteoporosis that would, over the course of many years, leave a Martian colonist with bones that are dangerously brittle and are at a very high risk of fracture. A similar and a more immediate process would happen to the muscles. The great and the powerful and the weight-bearing muscles of the legs and of the hips and of the back would, in this gentle and in this low-gravity environment, simply not be needed as much. And so the body, in its quest for efficiency, would allow them to slowly and gently waste away. Even the heart, the most important of all our muscles, would be affected. It would no longer have to work as hard to pump the blood uphill against the strong pull of gravity, and so it too would slowly and gently weaken and shrink over time. To fight this relentless and this quiet and this physical decay, the first Martians would have to dedicate a significant portion of every single day to a grueling and a difficult and a medically prescribed regime of exercise, working for hours on special and on powerful and on resistive machines, all in a constant and a lifelong and a necessary battle to convince their own beautiful and their own terrestrial and their own well-adapted bodies that they have not yet, in fact, arrived home. The first human outpost on Mars is now a place of beautiful and of hard-won and of sustainable and of technological and of biological peace. The great and the quiet machines are providing a steady and a reliable supply of air and of water, and the gentle and the purple and the artificial light of the great subterranean greenhouses is nurturing the first and the most precious and the most hopeful of all Martian harvests. The great and the immediate and the life or death challenges of the physical environment have for now been met, but the great and the silent and the beautiful and the profoundly alien landscape of Mars presents another and a much more subtle and a perhaps even more difficult set of challenges. For the most unforgiving of all the great, empty deserts is not the one that lies outside the habitat wall. It is the one that can grow in the quiet and the fragile and the deeply human landscape of the mind. The first and the most profound of all these psychological challenges is the tyranny of distance and of time, as our imaginary spacecraft made its long and its 7-month-long journey to the Red Planet. Its crew would have slowly and gradually become accustomed to the silence of a one-way conversation. The radio signals that carry our voices and our data travel at the fastest possible speed, the speed of light. But the gulf between the worlds is so vast that even at this incredible speed, a message from the Earth can take as long as 22 minutes to reach Mars, and a reply will take another 22 minutes to return. This is not a conversation. It is an exchange of letters. It is a series of quiet and of lonely and of time-delayed monologues sent out into a great and a silent and an unanswering void. For the first Martians, this would be a permanent and an unchangeable fact of their new lives. They could send a message of a great and a beautiful and a new discovery back to their colleagues on Earth. but they would have to wait for almost an hour to share in the joy of the reply. They could receive a message of a great sadness, of a loved one who has fallen ill back on their old home, but they could not offer your comfort or their love or their support in the moment that it is needed. All of their connections, all of their relationships with the 8 billion other human beings that they have left behind would now and forever be conversations with the past. And this great and this profound and this beautiful and this terrible sense of separation would be reinforced every single night by the view from their window. For all of human history, the earth has been our entire world, the great and the solid and the seemingly infinite ground beneath our feet. It is the very definition of home. But from the surface of Mars, the earth is no longer a world. It is a star. On a clear Martian night, it would appear as the single brightest and most beautiful point of light in the entire sky, a brilliant and a steady and a distinctly bluish-white evening or morning star. It would be a sight of almost unbearable beauty and of almost unbearable loneliness. The overview effect, the profound and the beautiful and the life-changing sense of connection and of unity that our astronauts feel when they see our blue and white world from a low Earth orbit, would be transformed into a new and a more somber and a much more lonely Martian perspective. To see your entire home, your entire history, and every single person you have ever known or loved, all contained in a single and a beautiful and a distant and an unreachable point of light would be a constant and a quiet and a powerful and a deeply humbling reminder of your own profound and almost absolute isolation. And this great and this external isolation would be mirrored by a new and an internal and a profound sense of confinement. The lives of the first Martians would be lived almost entirely inside. Their world would be a small and an enclosed and an artificial and a carefully managed environment, and their social world would be equally small. They would be living and working and eating and resting with the same small group of their fellow pioneers day after day, and year after year, with no possibility of escape and no possibility of ever meeting a new person. The vast and the beautiful and the empty and the silent and the red desert that lies just outside their window would be a constant and a beautiful and a terrible reminder of their own small and fragile and unchanging and enclosed reality. And woven into every single moment of this new life would be a quiet and a constant and an ever-present and a low-level awareness of risk. A tiny and a microscopic and an unseen tear in the wall of the habitat. A small and a quiet and a single malfunction in the life support system. A tiny and a hairline crack in the visor of a helmet. Any one of these small and these simple and these almost insignificant mistakes could lead to a rapid and a final and a fatal end. And so, the first and the most important of all the human qualities that a Martian pioneer must possess is not courage or intelligence or strength, although they will need all of these things. The most important of all the qualities will be a quiet and a patient and a profound and a deeply held and an almost sacred sense of mindfulness. The first human beings to call Mars their home will be a very special and a very specific kind of person. They will be the most brilliant of our scientists, the most skilled of our engineers, and the most resilient of our explorers. They will be masters of technology and of geology and of biology. But their greatest and their most profound and their most difficult work will not be the maintenance of their machines or the farming of their food. The greatest challenge of all will be a human one. It will be the quiet and the patient and the multi-generational task of building not just a habitat, but a culture, a society, a new and a distinctly Martian way of being human. A new and a unique environment will, inevitably, give birth to a new and a unique kind of human society. And the society that is born from the red and the silent and the unforgiving soil of Mars will be profoundly different from any that has ever existed on Earth. The first and the most powerful of all the forces that will shape this new society is the absolute and the undeniable necessity of interdependence. Here on Earth, in our vast and our robust and our incredibly forgiving biosphere, the illusion of rugged individualism is a possible and an often celebrated one. But on Mars, individualism is a fatal luxury. In a small and a fragile and an enclosed habitat, where every single breath of air and every single drop of water is the product of a complex and a life-critical and a shared technological system, the survival of each individual is completely and utterly dependent on the meticulous work and the psychological stability of every single other person in the community. A single and a careless and a thoughtless mistake by one person could lead to the death of everyone. This constant and this shared and this life or death reality would over time forge a culture that places an immense and a sacred value on the ideas of cooperation, of duty, of community, and of the collective good over the desires of the individual. The heroes of Martian society would not be the conquerors or the disruptors. They would be the quiet and the patient and the reliable maintainers, the engineers who keep the air breathable, the botanists who keep the food growing, and the psychologists who keep the small and the fragile and the precious community healthy and whole. The second great shaping force of this new culture would be the profound and the absolute reality of scarcity. The first Martians will be the pioneers of a new kind of living, a life of an almost perfect and a beautiful and a necessary efficiency. The very concept of waste, as we know it, would simply not exist. Every single thing in a Martian habitat, from a single drop of water to a single spent piece of equipment, to the very air that the colonists exhale, would be an infinitely precious and an irreplaceable resource. This would lead to a culture of the most profound and the most sacred respect for the material world. The idea of a disposable object would be an almost obscene one. Every single tool would be maintained, and would be repaired, and would be repurposed, and would be recycled over and over again until its constituent atoms could be used to print something new. This would not be an environmental choice, as it is for us. It would be the fundamental and the unchangeable and the beautiful and the necessary law of survival. And from these deep and powerful and environmental pressures, a new and a distinct and a unique human identity would, over the course of generations, begin to emerge. The first children to be born on Mars will be a new and a historic kind of human being. They will have never known the feeling of a strong and a heavy and an earthly gravity. They will have never known the sight of a great and a blue and an open sky. They will have never felt the sensation of rain on their skin, or the smell of a wet and a living and an earthly forest. Their only home will be the red desert and the pink sky and the quiet and the enclosed and the technological womb of the habitat, and their connection to the distant and the beautiful and the blue and white star in their night sky that is the earth will be a connection of history and of heritage, but not of home. They will not be Americans or Chinese, or Nigerians or Europeans. They will be, in the deepest and the truest and the most profound sense of the word, Martians. And this new, and this Martian, and this human culture will create its own new and beautiful art. Their stories will not be of ancient kings and of forgotten wars on a world they have never seen. Their myths will be the stories of the first and the heroic and the almost legendary explorers who made the great and the perilous journey before them. Their paintings will be filled with the deep and the ruddy and the beautiful reds and the oranges of the Martian desert, and the profound and the beautiful and the quiet and the almost spiritual blue of a Martian sunset. The great and the final and the most beautiful of all the Martian landscapes will be the one that is built in the quiet and the patient and the resilient and the deeply human heart of the colonists themselves. The first Martian society has now taken root in the quiet and the careful and the deeply interconnected communities that have been forged in the Red Desert. A new and a unique and a resilient branch of the human family is beginning to grow. We have, in our long and our patient journey, explored the profound physical and the even more profound psychological challenges that these first pioneers will have to overcome. Theirs will be a life of incredible difficulty, of constant vigilance, and of a deep and an almost absolute isolation. And yet it will also be a life of a profound and a beautiful purpose. But the story of humanity is not just a story of survival. It is not just a story of adapting to our environment. It is also, and has always been, a story of shaping our environment. It is the story of a species that does not just live in the world, but which, for better and for worse, remakes the world in its own image. And so, we now come to the final and the most audacious and the most beautiful and the most almost impossibly ambitious of all our Martian dreams. This is the story of terraforming. The word itself is a beautiful and a powerful one. It means quite literally earth-shaping. It is the process, the great and the multi-millennial and the almost godlike project of transforming the entire planet of Mars from the cold and the dry and the red, and the nearly airless world that it is today, into a second and a living and a breathing and a blue and white world, a new and a welcoming and a beautiful home for our species, and for all the other terrestrial life that we would bring with us. This is not a dream of building a small and a fragile and an artificial bubble of life under the ground. It is the dream of turning the entire planet itself into that bubble. The ultimate and the most beautiful goal of terraforming is to create a world where a human being could, one day, stand on the surface of Mars, on the shore of a great and a beautiful and a newly formed Martian ocean, and could look up at a rich and a thick and a beautiful blue sky, and could take a deep and a full and a wonderful breath of the open Martian air without the need for a helmet and without the need for a suit. This is the great and the final and the most powerful of all our pioneering dreams. And for a long time, it was a dream that belonged only to the gentle and the forgiving and the beautiful realm of science fiction. But in our modern age, it has, for the first time, become a subject of real and of serious and of quiet and of patient scientific speculation. Of all the worlds in our solar system, Mars is by far the best and the most promising candidate for this great and audacious project. For Mars is not a completely dead world. It is, in a very real sense, a sleeping one. And the great and the beautiful and the essential ingredients that are needed to awaken it, the very raw materials that are needed to build a new and a living biosphere, are already there. They are simply locked away in a deep and a planetary scale and a frozen slumber. We now know with a beautiful and a scientific certainty that the planet has colossal and almost unimaginable quantities of frozen water ice, both in its great and its layered and its beautiful polar ice caps, and as vast and as ancient and as buried glaciers that are hidden just beneath the surface of its red and dusty soil. And it has an even greater amount of frozen carbon dioxide, locked away both in its southern polar cap and chemically bound within the very minerals of its rocks. And these two, simple and beautiful and frozen substances, water and carbon dioxide, are the two great and life-giving ingredients that are needed to perform this act of planetary alchemy. If the first Martian pioneers could somehow find a way to gently and to patiently heat the entire planet, even by just a few crucial degrees, they could, in theory, trigger a deliberate and a beautiful and a self-sustaining runaway greenhouse effect. A small and an initial and a gentle warming of the planet would begin to sublimate the frozen carbon dioxide at the poles, releasing this powerful greenhouse gas into the thin Martian air. This new and this thicker and this carbon dioxide-rich atmosphere would then begin to trap more of the sun's heat, which would in turn warm the planet even further. This further warming would then release even more carbon dioxide and would eventually become warm enough to begin to melt the vast and the ancient and the beautiful reserves of water ice. The release of this water vapor, an even more powerful greenhouse gas, would then accelerate the process even more in a great and a beautiful and a planetary scale and a self-perpetuating feedback loop. This is the great and the beautiful and the quiet engine of terraforming. A small and a gentle and an initial push that could, over the course of many long and patient centuries, awaken a sleeping world. The great and the beautiful and the audacious dream of a new and a blue and a living Mars is now, in our minds, a real and a tangible possibility. We have, in our journey, come to understand the science of this great and patient act of planetary alchemy. The raw materials are there, locked away in the frozen ice caps and the dusty, red soil of the planet. And the process is understood. A small and an initial and a gentle warming of the planet could trigger a beautiful and a self-sustaining and a runaway greenhouse effect, the great and the quiet and the patient engine that could, over the course of many long and slow millennia, awaken this sleeping world. And so we are now left with the final and the most monumental of all the great Martian questions. We know the destination, and we know the path. But how do we take the first and the most difficult and the most crucial first step? How can a small and a fragile and a young human civilization possibly generate enough energy to warm an entire and a frozen and a desert planet? This is the science of world building. The first and perhaps the most elegant and the most beautiful of all the proposed solutions is a project of a truly cosmic and a majestic scale. This is the idea of the orbital mirrors. In this vision, a future and a much more advanced human civilization would construct a series of colossal but incredibly thin and lightweight mirrors in a high orbit around the planet Mars. These mirrors, perhaps hundreds of miles in diameter and made of a shimmering and an ultra-thin and a mylar-like material, would act as artificial suns. They would be positioned to capture the sunlight that would otherwise miss the planet and to reflect that gentle and that precious and that life-giving energy down onto a specific and a carefully chosen target on the Martian surface. That target would almost certainly be the great and the beautiful and the brilliant white southern polar ice cap, which we now know is composed almost entirely of frozen carbon dioxide. This constant and this gentle and this focused beam of extra sunlight would act as a slow and a patient and an incredibly powerful heat source, gradually raising the temperature of the ice cap until it begins, at last, to sublimate, releasing its vast and its ancient and its precious stores of carbon dioxide back into the thin Martian air. A second and a more direct and a perhaps more immediately practical approach is the factory model. In this scenario, the first Martian colonists would dedicate a significant portion of their energy and of their resources to building great and automated and robust factories on the Martian surface. These factories, powered by vast and by ever-expanding arrays of solar panels, or by safe and by efficient and by next-generation nuclear reactors, would have one single and simple purpose: to pump powerful and artificial and man-made greenhouse gases into the atmosphere. Scientists have identified a class of chemicals such as perfluorocarbons or PFCs, which are thousands upon thousands of times more effective at trapping heat than carbon dioxide. A small and a steady and a patient release of these super greenhouse gases could, over the course of a few centuries, be enough to warm the entire planet and to trigger the great and the natural and the self-sustaining feedback loop of the sublimating natural carbon dioxide from the poles. And a third, and a more violent, and a more dramatic, and a much more controversial of all the proposed methods is the impact approach. This idea suggests that we could, with an almost unimaginable level of future technology and of celestial navigation, gently and precisely redirect the paths of the small and the icy and the ammonia-rich comets and asteroids that are currently drifting in the cold and the dark and the distant reaches of the outer solar system. We could then guide these small and these icy and these volatile-rich bodies on a new path, a path that would end with a direct and a deliberate and a powerful impact with the surface of Mars. The effect of such an impact would be twofold. The immense kinetic energy of the collision would be instantly converted into a colossal and a beautiful and a powerful burst of heat, and the substance of the comet itself, the frozen water and the ammonia, would deliver new and precious and life-giving and much-needed volatile materials to the Martian atmosphere, adding both to its mass and to its heat-trapping ability. But no matter which of these great and audacious and almost unimaginable projects our descendants might one day choose, the one great and final and most humbling lesson of terraforming is the lesson of time. This is not a project for a single generation or for a single century. Even with our most powerful and our most optimistic and our most beautiful of all possible technologies, the initial phase of warming the planet and of thickening its atmosphere enough to create liquid oceans would likely take many hundreds and perhaps even thousands of years. And the final and the most patient and the most biological of all the steps, the great and the slow and the quiet work of seeding those new oceans with life and of planting the first green Martian forests and of waiting for those great and new and beautiful ecosystems to slowly and patiently and gently transform the carbon dioxide-rich air into a breathable and an oxygen-rich atmosphere is a task that would take many, many thousands, and perhaps even hundreds of thousands of years. The great and the beautiful and the final dream of a blue and a living Mars is a dream that belongs not to us, but to the very, very deep, and the very, very quiet, and the very, very patient, and the very, very distant future of our species. Our long and quiet journey to the red planet is now complete. We have traveled across the dark ocean of space. We have stood under its strange pink sky, and we have explored the immense and beautiful challenges of survival. We have seen how the first human home will be built, how its air and its water will be made, and how a garden might one day grow in the ancient, alien soil. And we have ended with the grandest of all human dreams, the patient and the multi-millennial, and the beautiful story of terraforming. The story is now told. The great and patient work of building a new world will be a task for our distant descendants. But for you, tonight, the only task that remains is the simple and the quiet and the gentle work of your own personal renewal. The journey is over, and now you can rest. Let the red sands and the blue sunsets fade. There is only the quiet, only the calm, and the gentle invitation to drift off into the deep and the peaceful and the star-filled space of your own dreams. Rest now. Just rest. The journey continues, always calmly, always at the pace of the universe.